Okay, it's 2 past 3 p.m. Good afternoon, everyone. My name is Baptiste Pai, and with Adeleke Maradessa, we are two teaching assistants in the class code 1270 of Professor Lee. And today we are very happy to welcome Dr. Yuan and Dr. Chang to join us for a seminar. Dr. Yixin Yuan is a senior researcher at the Hong Kong Center for Construction Robotics, where he leads research efforts in the development of numerical and analytical methods to solve practical engineering problems. He received his Ph.D. in Geotech Engineering in Prof Andrew Whittle's lab from MIT in 2016, and he has worked as a professional engineer in the USA for 5 years. With over 10 years of research experience, Dr. Yuan's interests lie in numerical modeling, in civil engineering, robotics, and AI in automating construction. Now, Dr. Ching-Wei Chang is a researcher at the Hong Kong Center for Construction Robotics, where he focuses on developing IoT for and autonomous PC wall installation solutions for construction environments. He obtained his Ph.D. degree in mechanical engineering from the Hong Kong Polytechnic University, specializing in UAV infrastructure inspection applications and multi-modal robot systems. So welcome, Dr. Yuan, and welcome, Dr. Chang, and the floor is yours. Thank you.
Thank you, Baptiste. Good afternoon, everyone. Great pleasure to be here, and thank you, Professor Lee's invitation. Greetings from Science Park. I'm Yixin from Hong Kong Center for Construction Robotics, and as you see, actually, we are located in this beautiful Science Park, and not too far away. So we also, warmly invite anyone who interested and drop by and just to check us out. So a great pleasure to give a brief introduction about who we are and what we are doing here. So let's say our center, Hong Kong Center for Construction Robotics, established in end of 2020. And that's a joint collaboration from UST and also UC Berkeley and Ching-Wei University. The name tells itself, right? So this center actually is to bring the robotics, the AI technology and all this advanced technology, and to upgrade construction industry. What we want to do is we want to offer a platform to join the industry partner, university like us, and researcher, and also government. All together, we form a joint force, and to do something different for construction industry. But unlike all the traditional academic research institute, we not only, let's say, writing proposal, publishing paper or something, we really want to do something down to the ground, right? To make some real impact, immediate impacts, to solve the immediate problems that faced by the construction industry. Our approach, our goal is to form some small teams and to let them to find the pinpoints of in the different area in the construction, and to develop prototype, and eventually we use all these teams to form a startup. We believe that startup, these small teams, these young engineers like you sitting in front of the screen, actually are the major workforce that will change the industry in the future. So we really want to use this form and to transform. So that's what we're trying to do. So some background information here about why construction, why we want to jump into this industry. So first of all, I'm a civil engineer. I've been in this industry for almost 10, 15 years. They used, let's say in China or in mainland here, the construction industry used to be one of the major pillar industries, right? So it contributes to the GDP 9% used to be, although it's declining, but it's still to be a major contributor here. And the increase actually declining, but amount, the great amount, is still to be 30 trillion RMB, and it is still quite a great economic impact here. But what this industry facing, or what are the major problems are, as several of you may heard from the news. First, it's a labor shortage. Well, we used to have quite a number of engineers in the industry. However, most of them are aging, and as in the bottom actually showing here, there are quite a lot of workers has already passed their 50s, and in Hong Kong, let's say the number actually even get more bizarre. The average workforce, the middle age are 55, and there are quite a few 20 or 30 young workers join this industry. So it faces a quite severe shortage in the labor. And another thing is the cost of the labor cost. Well, one is shortage, another is the increase of the cost. In Hong Kong, actually, the average labor would be 20 Hong Kong dollars per day. That's actually, it's a quite high cost for just tying the rebar, or for welding the steel structures. So the expense of the construction industry has increased dramatically. So that's the major two issues here. But if we go to if we dig a little bit deeper, we can see there are more problems about this industry. One is, if we compare the automobile industry, one is in 19 and the other is 2000-ish, they have undergoing a tremendous change right before you see the just the manual workforce on the left-hand side, and the other one is all the automatic, all have been automatic, the production line. However, on the bottom for the construction industry, sorry, this is we use the Chinese slides and mix with English, but just let me describe this. Now on the left-hand side, that's 100 years ago, the construction industry, and on the right bottom hand, it's just nowadays. Not much changed, right? So it just tells us something. This industry is not only we're shortage in labor, but may have other factors that makes the young engineers not like to join this industry anymore. Nothing changed. There are no fancy technology. They used to use the wrench, used to screwdriver, all the manual tools. It's still the same. And why? That's one of the question, one of the problem we're trying to address here. Well, in just a little bit summary here, we are facing increased, gradually increased cost and the labor shortage. On the other hand, many construction problems still has to be done in a manual way, in a quite old-fashioned way, and the efficiency, as you can see, it's not that high. So the construction period is generally prolonged and generally delayed. And on the other hand, in Hong Kong, we're also facing a quite severe problem. Is we're still using this bamboo scaffolding. So there are quite a lot of safety issues, and sometimes you heard the news, the tower crane just collapsed. The safety issue is also another thing that young engineers just don't want to join this industry anymore. And also here, well, as we all are aware that the construction sites, the first impression is they're quite messy, quite dirty, and a lot of waste. And so all this old-fashioned way just produce so many waste, and how we can deal with that. So there are many things we have to change, to upgrade, and to make this industry to be more appealing, to be more effective, more safety, and more safer, and so that we can produce a much efficient and well, to lower the cost, to increase efficiency, and to upgrade this industry in short. Okay. So, well, we're not the only one that wear this. The nation, the whole country actually trying to make this change from the top down, from the government level. By 2025, we're trying to use some high technology like robotics, AI, and trying to produce several high-end robotics production and products, and to apply to this construction industry. And so they have promote what you call so-called the 14th 5 years planning, and to use IoT, to use AI and the multi-robotics collaboration, and to provide several benchmarks. So they can use robotics to replace the dangerous, tedious, dirty, and unsafe construction, or they can use the AI and the much high-end digital technology, and to digitalize this whole workflow. And here in Hong Kong, actually, there are several ongoing changes in this industry. I just want to point out here. Actually, we're quite proud we're in Hong Kong, and we have several new trend. Here, one on the left, the top left is the so-called modular integrated construction, and several from I assume several one may heard this. If you are from the civil engineer department, you may aware this too. So in general, this is what is this, all the blocks is the so-called modular, right? And all this house, actually, they are all these rooms, they are produced in a factory in mainland China, either in Huizhou, Zhuhai, in several other places. And when they finish these blocks, they've been shipped, transported through the shipyard, and they landed in either in a harbor in the Hong Kong Island or here in Keelung. And then they transport each block through the highway, and when they arrive to the construction site, all the blocks will be lifted and stacked one by one, and to perform like a block, like a Lego blocks, right? And to form this whole building. So this new way is called modular integrated construction. The very typical example I can give is the Quarantine Park in Penny's Bay, right? There, if I recall correctly, they produce 40,000 the rooms in 4 months. 40,000 house, 40,000 rooms in 4 months. That's a quite effective way. That's a new, very efficient way to build out the new buildings. And if you imagine, if the northern metro area, if Hong Kong government want to build about 30,000 public housing, they want to use this way, then that would be a quite massive construction activity there. So that's a very new, efficient way. And another way is the Hong Kong has established this so-called Construction Industry Council. So this council promotes several very cool and very advanced high-tech technology, and trying to promote their application in the construction. As the drones and what is the LiDAR equipment. There are several new treatment of either the 5G, or another one is this the skeleton, the exoskeleton, and there are other new technology like the painting robots, and the scanning LiDAR scanning robots, and all the other. So Hong Kong has put quite efforts to promoting all this new technology to be applied and in this industry. So that's all the background information. That's where we stand, and that is why our director, the founder of this center, Professor Zexiang Li, who saw their opportunity that as a UST researcher, as all the researcher who interested in this construction, automatic construction industry here, we can make a change under this circumstance. In Hong Kong, we have a trend trying to use new technology and to upgrade. And so, first of all, Professor Zexiang Li, very well known, and he's a professor from UST, and he's also co-founder of DJI. And in 2020, he founded this Hong Kong Center for Construction Robotics. But he's also what we used to call him the godfather of several of the new startup. So he contributed incubated several of these novel, the Yunjing and EcoFlow and CD, the autonomous driving company, High Robotics, and also, along with all this, the long list, we hoping that through our center, we can incubate several of the new company that focused in the construction industry. So here, the center we established in, this is timeline, we established in 2020, the end of 2020, and we started recruiting several students and to form the startup teams in 2021, let's say the September, and then throughout the whole 2021, we have held several summer camps, and we hold several online seminars. Of course, there were during the COVID time, but in 2022, we started to gather up. We started to have the summer camp, and also we recruiting second years, the HKCRC UST collaborative so-called MPhil program. And so we are having 12 or 10 plus teams and more. We have trained, we have enrolled more than 300 summer camps and several of the seminars, several of the training. And we have 20 collaborated professors, and it's still ongoing. Actually, later, Dr. Chang will give us more detailed introduction about what each teams are focusing on and what technology they have been developed. In general, the scope of our center, let's say this center has focused on a quite large spectrum of the research scope. It's generally throughout this whole industry, the whole construction workflow. So we're focusing on how to use AI to upgrade the design and planning, and later how to upgrade it to make intelligent construction process. And also, in particular, in Hong Kong, we have strong interest into the so-called prefabrication manufacturing, and particularly the MIC, the model integrated construction, and also how we can develop AI models and the algorithm, and also the IoT sensors trying to capture the data in a smarter way, and how to process this data, and how to use the data to increase efficiency of the construction workflow. Now, this is just a snapshot. So currently we have about 12 teams, and several teams already, they early enrolled, and they already have several prototypes. I can just give you a glimpse, and Dr. Chang will give more detail. And let's say we have some what we call the mover. This machine can lift and moving about the 1.5 tons, the ALC, the construction wall panels, the concrete wall panels. And this little guy actually can laying and paving these waterproofing sheeting materials. And they used to be a man with a torch. It's the torch and to heating this sheeting and to lay on the ground. It used to be a quite dangerous job. And we also have this one is a high precision floor grinder robots. It can be used for either the garage or the let's say basketball field or some airport buildings. And we also have this is a 3D reconstruction of the palace in Hong Kong. And we also have this photo measuring device. When we take a photo, actually we can use AI algorithm to capture the edge of the building material, the wall panel, where the big window is, where the MEP, and we can use the 3D camera to measure the dimension to do inspection. And these are the autonomous, the tilt up mechanism that can help engineer to efficiently erect this, to efficiently install this the prefabricated wall, and also with some IoT sensors. Dr. Chang will introduce more. And this is still a conceptual design, but those guys already have some prototype here. They're trying to use this semi-automatic mechanism to tie in the rebars. This has attracted a lot of attention, as right now currently there are only a manual way trying to tie in this rebar, and it's not that accurate. So they're trying to develop a robot that can increase efficiency by 5 times. It's quite cool projects. Yeah, so that's just a quick walkthrough of what we are doing. And so what I want to add is that we're still recruiting. We currently we are holding what we so-called the summer camp. As you all know, there are a long summer break, and if you have nothing else to do, and you can check us out here. And we generally open 3 weeks or 4 weeks summer camp, and we let the students to going touring in the construction site. So first to find the pinpoints on what are the real problems that faced in the construction industry. And then we divide into each groups, and each groups will brainstorming what solutions they can propose, and they iterate on their propose and debate, and eventually they can build a prototype in about 2 weeks. Of course we found all the keys tools, and then by the end of the camp, maybe down to 3 weeks, each team will give a pitch, give a presentation, okay? And you have to convince us, okay, this will be the device, the prototype, the solution that you developed really works and can help construction, can help either contractor, surveyor, inspector, or real estate developer who can really get their job done in a much efficient way and can really solve the job. Then you will be eventually you will be awarded a small prize, but actually if you really do a fantastic job, and then you may grant a funding and join us as one of the small teams, and eventually you can join us as go through the startup eventually to spin off and get some VC funding. So that's what we're trying to promote here, and this is one of the summer camp. So okay, so here is just a short short description on how we incubating this one. So eventually, each team join us. If we want to go to the startup path, we will have 3 months to give you market investigation, and we develop a prototype, and then we build a team, and by the end of the year we will validate our prototype, we'll do some marketing validation and spin off. So that's generally the the route. So I guess I ran out of time. So here we have, so eventually we want to combine the marketing resource, our talent resource, our government, and our researcher facility, and we're trying to make a joint force to make a much better future for construction industry. And of course, we work closely with all the partners in Hong Kong and in mainland. And yeah, that's some of the snapshot of what we are working. And you see several guys that work really hard during the summer camp. They just sleep here. Right, in summary, this is a really fantastic platform, and you have the chance to pursue what you really want and build your own startup. Eventually, it can grow into some bigger company, who knows, right? Thank you. That's what I wanted to share.
Thank you, Dr. Yuan. Yeah. Can everyone see the slides? Okay. So I think Dr. Yuan did go through some of my contents that I want to introduce. So I will mainly focusing on introducing what have been done in our research center and give a brief introduction of the construction industry and what we are going to add on robotics things into this industry. So I will just give me a brief introduction of the current new trends of the construction industry. So I think Dr. Yuan did introduce that we are now starting to implement new components that we called precast concrete and also some MIC components into this industry. And so in this kind of components, we will precast this kind of components in mainland China or mega factories, and then we will ship them into Hong Kong or maybe major city like Shanghai to get installed. And by this kind of techniques, the cost and also the pollution can be greatly reduced. And then that we were majoring doing is robot things in the construction industry. So the engineers start to think of how do we optimize the workers' time and also reduce the labor intensive things in this industry. So many companies same as us try to start to design and design some robots to implement to this industry. So in this picture, this company made this robots that is made for laying down some special waterproof tiles and materials in a building. And by using this kind of robots, the labor time can be reduced by 20 times comparing to manually using labor to lay down these materials. And at last, I think everyone now is pretty familiar with UAV and SLAM and LiDAR stuff. So this kind of technology are also implemented to the building industry, that we can use LiDAR system to make and SLAM system to make a so-called digital twin of the building and also the construction site. By using this kind of a digital twin, the companies can start to track and also do some management and quality inspection of the construction site. This is very helpful for the BIM system in the current industry. So these three are the three major trends that we are going to implement into the labor intensive construction sites. So let me start to introduce some of the robots that we are developing in our research center. I think most of them, like Dr. Yuan did mentioned before, but I'll give some like much more detailed things. So the first one is which called their team name is Zoe Robotics. They are mainly focusing on dealing with robots with this kind of materials. This kind of materials is called ALC panel. ALC panel, comparing to PC components, they are lightweight, and used in the inner wall of some building. Also, we call it lightweight, but they're still pretty heavy. Like in this robots, it can easily lift up 5 to 6 ALC panel, and all of these panels will go up to like 1.5 tons. And by using this small robots, they can control the robots and easily lift up the panel and go into the elevator in a construction site, and easily and carefully move this panel to a certain point. The panel is going to be placed. And why we need this kind of robots? Because like usually workers need to use small carts and manually push this kind of panels into place, and usually workers might destroy or ruin some panels. And by calculation, like sometimes up to 10% of these kind of panels will be destroyed within the transportation of this panel to the right place. So they design this kind of robot to help these things. And second, it's a Skyline Innovation team, and by their team, they design a handheld, small scale, and pretty lightweight LiDAR scanner for building reconstruction. This is the first prototype of their scanner. Their current prototype is much more smaller and much more easier to use. And what they've done is they use LiDAR scanner to get 3D model in a handheld way, and they can instantly rebuild the whole building 3D model in their small equipment, and no need to post-process of the 3D model. And also, what is pretty new in their small equipment, they did like added some RGB cameras on their equipment, and by the same time, the 3D model can be colored into RGB scale that mostly the current things on the market cannot do. And so this is what we're inventing for the industry. And the third one is what is Dr. Yuan is majorly developing. So so their team is developing a AI-based camera that equipped with like stereo cameras which can measure 3-dimensional stuff just by taking a picture, but not using a LiDAR scanner to need to like go around all the things to get a 3D model. So by the camera, they not only can measure all the 3-dimensional things, but also they added a lot of AI object detection techniques that can, by taking a single photograph and detect the whole like just for example, by taking this photograph, the camera can automatically grab up this is a PC wall that laying on the structure, and also all of the rebar hanging out of the PC wall can be recognized, and also the dimension and all of the numbers of the rebar, and also the volume and the dimension of the PC wall can be measured just by a simple snap. So comparing to traditional measuring way, this can be like reduce a lot of labors to using rulers to measure a single PC wall or any kind of construction site scenes. So this is what the Korean team is like majorly developing. And next, this is the team that is focusing on building up some components that is made for PC wall installation. So on the left, we can see this picture. This is what workers are using right now in a construction site in Hong Kong. And so we can see, like, by installing this one wall, a worker need to use a rule to use an instrument to measure the verticality of the wall, and telling another worker to tune the length of the rod to place this PC wall into a great verticality way, and also its position. So what they've done is they designed a small sensor that can installed on the PC wall, and this small sensor can connect it to a lot of modularized electric controlled brace, and just by a single sensor, the sensor can control up to like 6 to 9 brace at the same time. And by the reading of the sensor, the brace system can automatically push the PC wall into a perfect accuracy of the PC wall verticality. And yeah, so, and also we did a lot of AI trial in our center too. So in the left, we did some helmet detection AI research. That this system we did like tested in the construction site. This system is contained with a small camera with a speaker. That a small camera can detect the worker if the worker did or did not wear a helmet in a construction site. And if the worker did not wear the helmet, the speaker would close to the camera will just warn the worker and tell them to wear the helmet. And also, I don't know if any of you have heard a news in Hong Kong that happened in Dawei. The Boao construction site happened an accident that this news just said, because of using a wrong number of the cement in a construction site, the whole building need to be tear down and rebuilt. So we also did a favor for some construction company that we build a database system, and using AI detection techniques to help them to detect the car plate of the cement truck, and also help them record the cement usage of the concrete, and also all kind of these things of usage to prevent this kind of accident happen again. So we also did a lot of AI trial in the construction site as well. And yeah, and this is some like specific picture, I think, like Dr. Yuan did introduce before. So this is another picture of the waterproof tile laying robot. So traditionally, people use like some flamethrower and things in the construction site, just helping this waterproof tile to laying down in the construction site. So because of the dangerous, we invent this robot that can automatically move by its own, and also uses heat and by electric, or sometimes flame as well, to put down the waterproof sheets in the buildings. And also some high altitude painting and grinding robots are also started to be developed. They are now currently in a prototype way, and this thing is pretty help the workers not going to too high environment and will like reduce some dangerous scenarios while in the construction site. And also the robots and right is the high precision ground grinding robots that's grind the ground to be a much more precise way. And also the rebar binding robot is in right bottom side. And yeah, and also there are like a lot of other robots that we did not put in the pictures because they are all in prototype way, and we are going to have patents on them, so they're not going to show in this way. And I'll just give some introduce like a tile putting robots we are now developing, and also some 3D printing robots that can print pretty large scale 3D printing materials that we can put in a construction site are also being developed. And also we're just like talking about ALC transportation, but ALC installation robots are also on the way. And yeah, so all kinds of robots is going to be like developed in the center, and we are all welcome with all new ideas that can help the construction site to be less dangerous and more efficient. Yeah, and I think this slide Dr. Yuan did present before, and yeah, it's just so anyone want to be entrepreneurs is of course will be welcome to join our center, and we will always provide funding and also all kinds of help, industrial help, and all kinds of help to help the young entrepreneurs to succeed their prototype and commercial way. So yeah, thank you. So if anyone got question about our sensor, it's very welcome to be asked.
Okay, thank you so much, presenter. We really appreciate your insightful topic. It goes a long way in broadening our understanding regarding the course of interest. We really appreciate your time. So do we have any question? So you feel free to ask. Or you drop your question on the chat box.
Yeah, I think I've seen that Dr. Yuan did answer some questions.
No, only one. Yeah, how do I apply for the internship, or how many applicants do you hire as summer intern?
I will say if it's summer intern, there will be no limit because we always lack of help, and I also you can still apply. Where all the teams will be welcome, but because there will be no places for us to build large scale robots, so most of our teams that are building large scale robots are currently in mainland China, because we got a testing site in mainland China for large scale robots.
Okay, thank you.
Actually, I want to add one thing. Sorry. Just we're about to holding another summer camp in June, starting June 6th, right? If I believe I can pass the poster about the summer camp later. Yeah, to TAs, and probably you can help us to spread the news, and in this group, we welcome anyone interested. The summer camp actually would be 3 weeks, and there are number limits. I believe there are 20, but there should be fine. if you apply early, and if your background really fits, then we welcome. Yeah.
Okay. Okay. Thank you.
Like I said, yeah.
Yeah.
Thank you.
Do we have some other questions? So feel free to ask. No. So how long and okay, you've seen it. Okay.
Yeah. So summer intern and summer camp is actually a different thing, but actually if you got into summer camp, we will also give you a summer intern position in the center, but you're doing the summer camp stuff. But if a normal summer intern, you will be placed into either any research group, and if they are like lack of this position, they will contact you and give you a small interview, and you probably can enter some normal research group and not going to a summer camp. It's a different thing, but summer intern, yes, I think it's explains something.
Okay. Okay, thank you.
Yeah, thank you.
How do I apply for the internship? From which website?
I think we can pass some documents to TAs afterward. I guess normal internship should be you need to send the CVs to our HRs in the center, and all the CVs will be passed to all the group leaders to review.
Okay, thank you. So regarding the internship, so they will pass us the full details later. Then we'll communicate with you accordingly. Okay. So do we see any other question? So if no, we really thank you for giving us this opportunity to. No email. Yeah. Okay. HK. I want to save it on my phone. Oh, you have it. Okay. So thank you for giving us this opportunity, and we really appreciate your time and efforts in putting everything together. So, and we believe that the knowledge you share with us today will go a long way in making everything easy for us. So really thank you. So then we look forward to meet you and to have this kind of interesting topics together in the future. So thank you.